Welcome to Mrs. De Castro's chemistry class for Wednesday, 3rd September 2014. We are still on Standard 2 of Indiana's Academic Standards for Science, which is atomic structure and the periodic table. Our core standard describes how the structure of the periodic table reflects the numbers of electrons and protons and the configuration of electrons in atoms. Okay, let's start by recalling how we represent the atoms of an element. So we have XAB, where X is the symbol of the element, A, the subscript, is the atomic number, and B, the superscript, is the mass number. Let us also recall our definition of proton number, which is the same as the atomic number, and it is equal to the number of protons in the nucleus of an atom. It is also equal to the number of electrons in the neutral atom. Okay, so how are the electrons arranged outside the nucleus of an atom? And we said we can answer that question by way of the electron structure, which is the arrangement of electrons in the electron shells of an atom. And what are electron shells? These are the fixed spaces in an atom in which the electrons are found. And how do we distribute the electrons around the nucleus? We said we will use this chart here, which shows us the order of filling up of the orbitals. So we start with a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and so on and so forth, depending on the number of electrons in the atom. So for example, bromine, this is one of the items that you were struggling with yesterday. So bromine 3580, that means it has 35 protons, 35 electrons, and 80 minus 35 or 45 neutrons. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. And if we add up all the superscripts here, okay, they would sum up to 35, which is the number of electrons that we are distributing for bromine. So the orbital diagram for bromine will look something like this. All right, so where you draw each of the orbital and showing that each orbital can only have a maximum of 2 electrons. Another way of showing the orbital diagram would be something like this. All right, you can also do this as long as you show each of the orbitals and the 2 electrons in each orbital. And if we were to do the electron dot symbol for bromine, it will be something like this, where you will have the nucleus with 45 neutrons, 35 protons, and then around the nucleus in concentric rings, you will have the electrons. So each of the main energy levels will have the corresponding number of electrons in the diagram. Now, shown here is your periodic table. At this point, I would like you to pause the video and to grab your periodic table and follow the rest of the presentation with your periodic tables. Right, so let's look at periodic table and atomic structure. So periodic table is the systematic arrangement of elements into groups and periods according to increasing atomic number. Again, atomic number is your number of protons, which is equal to the number of electrons in the neutral atom. So what are your groups? These are the vertical columns in your periodic table, so it's from top to bottom. They're also referred to as families. And you have periods, which are your horizontal rows. So it's from left to right in your periodic table. So I just want you to make the notations now in your periodic table. So your groups or families are your vertical columns, and there are 8 groups. So you have 1, 2, 3, 4, 5, 6, 7, and 8, right? And your periods or your horizontal rows, there are 7 of them, right? So 1, 2, 3, 4, 5, 6, 7. So your periods correspond to the number of your main energy levels occupied by the electrons of the atom. So for example, you have hydrogen, 1s1, helium, 1s2. So notice that their electrons only occupy the first main energy level, and so they are in period 1. Lithium and neon are in period 2. Why? Lithium's electronic configuration is 1s2 to s1. So notice that it has electrons in the second main energy level. Neon's electronic configuration is 1s2 to s2 to p6. So it has electrons in the second main energy level. Sodium and argon are in period 3. Look at sodium's electronic configuration. It ends with a 3s1, so that means it has electrons in the third main energy level. Argon's electronic configuration ends with a 3s2, 3p6, so that means it has electrons in the third main energy level. So again, can you just recall or remember that the period number is equal to the number of main energy levels occupied by the electrons of the atom. All right. Groups or families. This corresponds to, or the group numbers correspond to the valence electrons. And what are valence electrons? These are the electrons in the outermost energy shell of the atom. So if we're looking at lithium, notice that lithium is in group 1. Its electronic configuration is 1s2 to s1, so it ends with an s1. Sodium is also in group 1. Its electronic configuration ends with 3s1. And potassium is also in group 1. Its electronic configuration ends with an s1. Right? So the group number corresponds to the number of valence electrons. Let's look at other examples. Beryllium is in group 2. Its electronic configuration ends with an s2. Magnesium is also in group 2. Its electronic configuration ends with an s2. Let's look at boron. Boron is in group 3. Notice its electronic configuration ends with a 2s2, 2p1. If you add 2 plus 1, that gives you 3. Aluminum is also in group 3. Its electronic configuration ends with 3s2, 3p1. So if you add 2 plus 1, that gives you 3. Carbon is in group 4. Its electronic configuration ends with a 2s2, 2p2. So if you add 2 plus 2, that gives you 4. Nitrogen is in group 5. Its electronic configuration ends with a 2s2, 2p3. If you add 2 plus 3, that gives you 5. Now, there is a special group of elements in the periodic table, and these are your group 0 elements. So these are helium, neon, argon, krypton, xenon, and radon. So they are a special group of elements because they have a completely filled outermost energy shell, or your main energy level. So completely filled, that means they have 8 electrons, with the exception of helium, which has only 2. So for that reason, they are sometimes referred to as group A. So if we look at the example here, helium has 2 electrons. It has a completely filled first main energy level. Neon has 10 electrons. It has a completely filled second main energy level. Argon has 18. It has a completely filled third main energy level. So group 0, okay, remember group 0 elements have 8 electrons in the outermost electron shell except helium, which has 2. So I want you to make these notations in your periodic table. So valence electrons is equal to the group number of the element. And I would like, so group 1 elements, 1 valence electron, the electronic configuration ends with an S1. Group 2, okay, 2 valence electrons, the electronic configuration ends with an S2. Group 3, right? They have 3 valence electrons. The electronic configuration ends with a P1. Group 4, 4 valence electrons. Electronic configuration ends with P2. Group 5, 5 valence electrons. Electronic configuration ends with a P3. Group 6, 6 valence electrons. Electronic configuration ends with a P4. Group 7, 7 valence electrons, electronic configuration ends with a P5. And after that, you have the completely filled outermost shells, and this will be your group 0, also known as group 8. Okay, we will stop here, and we will work on our worksheets.